Let's say that we have a network in here and we want to send some packet in this from this device 192.168.1.2 to a web server which is acting in here and another network. We know that web servers usually listen at the port number 80. So what we want to do is to send packet to this web server in here. So in this device we open a web browser. When we want to send the data, the operating system would assign a port number in a specific range. Let's say in this example, the port number that has been assigned to the browser, to the program that is creating the communication, is equal to 50,000. Now the packet that is getting sent from this device to the router has these characteristics. The source address is 192.168.1.2 with the port number of 50,000, and the destination is equal to 5.5.5.5 with the port number of 80. 1.2.3.4 is the public IP address that the ISP or Internet Service Provider of this network has assigned to this router, and 5.5.5.5 is the public IP address that the Internet Service Provider of this network has assigned to this router in here. And then both these routers have assigned the private IP address to these different devices inside their own network. Now the router would look at the destination public IP address in the packet and it sees 5.5.5.5, which is a public IP address, so it knows that this packet should be forwarded outside the network. But now the source is in the private range, so this address should be translated to a public IP address because the router knows that the private IP addresses are non-routable. So what it does is that it would translate the private IP address to its own public IP address. And let's say that for this example also it would change the port number of 50,000 for this device to another port number. And it writes all this information inside a table. So in this case, the 192.168.1.2 with the port number of 50,000 has been translated to 1.2.3.4 with the port number of 40,000, as you see in here. Now, because both the source and destination IP addresses in the packet are in the public IP ranges, so this packet is routable for outside LAN communications. So it would be directed to the Internet Service Provider of this network. The packet would go to the upstream router in the ISP and would go through the internet based on some rules or protocol of forwarding the packet until it reaches the destination with the IP of 5.5.5.5 with the port number of 80. Now this router already knows that the only device inside its network which is listening to the port number 80 is this web server with the IP of 192.168.1.3. So the router would deliver this packet to this server. After the web server has seen the request and provided the corresponding response, it would create a packet and send to the router. In this case, the source address in the packet is 192.168.1.3 with the port number of 80 to the destination of 1.2.3.4 with the port number of 40,000. When the packet gets to this router in here, it would translate the private IP address of 192.168.1.3 to its own public IP address, which is 5.5.5.5. Now the packet is routable, so it would send the packet to the internet, and again based on some protocol it just moves until it gets to the destination. When this router looks at the destination, it sees that it is equal to 1.2.3.4 with the port number of 40,000. So it looks at its table, which is called the NAT table, and it sees that this address should be translated to 192.168.1.2 with the port number of 50,000. So it puts this address for the destination in this packet and send it to the device, to the originating device, which is 192.168.1.2, and at the port number of 50,000, the browser is listening. If the browser is listening for the response, it would accept the packet and moves it through the network stack and show it to us. This process is called NAT, or Network Address Translation, or PAT, or Port Address Translation.